Okay, so we looked at a few options. Two of the kind of options which were proposed was to either make the beams in-house, which would involve cutting these to length on a machine, and then we also looked at another option of buying the beams in from a supplier. Of course, we can see that there are pros and cons with both, being that you get greater control over the process and can respond rapidly to sudden changes in production by making the beams in-house. Although, of course, on a few drawbacks is that you get the higher kind of recurring costs and non-recurring costs, so to speak, associated with that. But then we also want to have a look at the option of buying beams from a supplier for risk mitigation, basically looking at reducing our inventory levels, although the downside is we may have issues with supply chain which could cause interruptions to production. And so, starting off with our make scenario, effectively we've modelled up what we think that our work cell we would need would look like in order to basically meet our rate of 200 a day in order to keep productivity on the production line. We're also assuming a shift pattern here of Monday to Friday from 8 until 5 in the evening with an hour for lunch. We're going to have 4 crew members which are manning the cell, which will be the machine operator, a crane banksman, a repair engineer, and also someone to transport the finished offcuts. And this will also involve an NC cutting machine and a crane for loading the cell effectively. And so, in order to look at our rate capability, we're going to run a simple scenario here where we can see we can also assess kind of how products will move within our cell. We can look at offcuts as well, so we can see that one operator is discarding of waste offcuts which are produced, while the other operator is sorting the useful offcuts, so we can track things like our environmental impact, how to improve return on investment, and quite simply just by clicking on these resources we're getting real-time data from production. And so what we can see is the crane kinematics. We can make kind of assumptions and decisions on supplier selection and how the whole system will perform based on how much the crane is utilized, traveling loaded, unloaded, loading or unloading, or empty, like you can see. We've just had a call that there's been a breakdown on the NC machine, so we've had a repair engineer which has repaired our NC machine and fixed it, and so we've now reached the end of our shift. So we can see that we've hit our rate of 200 in a day, which is great, although we need to produce 200 each and every day of the week. And we have had new information from our team that there will be basically some new complexities, including a 4-hour maintenance set of downtime, which will be required once a week in order to reset and repair all of the machinery and the lifting equipment. And we've also had news that some of our cuts are likely to have defects, and as a result they are likely not to conform, which will cause us to fail to meet our demand. And so if we just move on to another scenario which we have simulated using 2 NC machines as opposed to 1, which can basically